Hello, this is Rishav and this video is made for the demonstration purpose of OSM module or Oscillatory Stability Management module of BigSync application. So let's start the video. So I'll import the file here. So for the sake of this video, I'll test this application using two test cases. So I'll start with ISO case 1. I'll choose this file and click on Start Analysis. After that, we can see here that we have options to select a substation and a line in that substation. We can select a line and we can click on detect event. Before clicking on detect event, we can also specify different threshold values. Like first one is row of standard deviation threshold, which is used in the algorithm, and second is the window size. So these two things we need to provide to the algorithm. Before going further, I also want to demonstrate that we can also select multiple plots on the same plot. We can see here, and not only we can select frequency, which is by default selected, we can also select voltage magnitude, voltage angle, all those things. We can see one weird thing happening here is that if we are selecting voltage magnitude here, we are not able to select those threshold values and click on detect event button, because the algorithm that we have worked on is based on the frequency data. So we need to select frequency property for getting those things. So now I've selected a substation and a line, and I'll click on detect event here. So we can see here that we have an event detected in substation 5 line 11, which we selected earlier. After that, now we have detected an event, right? After that, we need to classify what kind of event is that. So as of now, this application can detect 5 different kind of events. First is impulse event, then oscillatory event, then islanding event, and generation load and load loss event. So for all those things, we need to set some threshold. So I'll want to keep the default threshold values here, and so after selecting the threshold values, I'll click on classify event. So now we can see that we have got oscillatory event as true. That means there are oscillations present in the system. If I want to see the data, we can see easily here. So now we know there are oscillations in the system, right? So now what we need to do next, we need to find the location of oscillation, right? So now for that we have some different modules. So I'll go on OSLP module, which is Oscillation Source Location Program. So I'll choose file. I'll choose the same file that I chose earlier, which was ISO case 1. I'll choose this file and I'll click on any substation and any line. So now this is saying that we need to select left and right point to create a window. So for the algorithm to work, we need to give a window. So for that we need to give left point and right point to make a window. So we can see that after this point some weird thing is happening. So we'll select this as our first point, and I want to make a window of around 20 seconds. So I'll keep around 56 seconds here. So we can see that we have starting time of around 36.566 with an end time of around 56.73. So now I'll click on locate the source. So after a few seconds, we got 5 most probable sources of oscillation. So we have got a nice table here in which we have ranking, we have lines, and we have DEF value. DEF is dissipation energy flow. So we can see that the most probable sources are substation 8 line 17 followed by substation 8 line 19. So these two are the most probable sources here. Not only we can see the ranking, we can also see the plots or flow of energy of these lines as well. So here substation 8 line 17 is plotted currently. We can select for substation 8 line 19, we can select for substation 12 line 28, So all these things we can do. So now we know that what is the most probable source of oscillation here. Now, if we talk from beginning, we have taken a data, we have checked that there is an oscillatory event in the data. We found the location of oscillatory event, which was substation 8 line 17 in this case, most probable source of oscillation. And after that, we need to characterize what kind of oscillation is that, right? So for that, we have one different module, which is oscillation characteristics module. So I'll choose a file. I'll choose the same file which I chose earlier. So I'll select substation 8 line 17, which I guess was the most probable source. Yes. I'll click on add data. I'll click on extract mode. So after a few seconds, we got the modes characterization here. So we can see we have detected two modes here. One is 0.087, but the energy contribution that it has, that is very less, so we won't consider that much. So we have a second mode of 0.293 damping frequency and amplitude of around 0.003, theta of 0.380, and percentage energy contribution is significant. So we'll consider that as a mode that we need to worry about. So I'll click on mode 2, and not only we can see the mode itself, we can see the amplitude, we can see instantaneous energy, we can see instantaneous frequency. So all these things we can do. So this was a demonstration of oscillation stability management or OSM module of BigSync application using IIT case 1 test case. So I'll do the same using some other test case. So I'll go back here. I'll choose some different file. Let's say I chose Kaiswani case 3. Again, I'll select some different data. I click on detect event. So I want to keep Rokov standard deviation threshold and window size as the default values. I'll click on detect event. Now it is showing that there is an event here. I click on set threshold and I'll classify the event. Now we can see here that oscillatory event, it is showing as true. So we can see the oscillatory event data. After that, since we know that there is an oscillation, there is oscillatory event present here. So I'll want to know what is the most probable source of oscillation here. So for that, I'll choose the same file here that we chose earlier, which is IIT case 3. I'll choose any file. Let's say I chose substation 4, line 8. Not only we can choose the window point using frequency property. We can do the same using voltage magnitude, voltage angle, that things also. So again, you can see that some weird thing is happening around 64 seconds. I want to make a window of around 20 seconds. So I'll choose a window of 20 seconds. And I click on locate the source. After a few seconds, we'll get the most probable sources listed here. The first one we got as substation 2 line 4, which has high DEF value. Second one is substation 2 line 2. So these two are the most probable sources of oscillation here. We can see the flow of energy of all these data as well. So now we know that substation 2 line 4 is the most probable source here. So I'll go in the oscillation characteristics module. I'll choose the same file. I'll select substation 2 line 2. I think that was substation 2 line 4. And then click on extract mode. After few seconds, we got after few seconds we got no, uh, after few seconds we got the modes present in this in substation to the input. So we can see here that these two modes, they are not very significant. Their damping percent are also very high, and energy contribution is not that much. So this is the mode that we need to worry about, which is 1.16 damp frequency and damping percent of around 1.14, theta value around 2.6, 2.55, and percentage energy contribution is also very high. So we can see I selected mode 3 from here, and you can not only see the mode itself but also the amplitude value, the instantaneous energy value, the instantaneous frequency values, all these things we can see. So this was demonstration of BigSync application using ISO NE case 1 and ISO NE case 3. Thank you for seeing this video.